Hey guys, this is going to be the first video in a series all about electronics. This is going to cover the big three brands, Garmin, Humminbird, Lowrance. They pretty well all function on the same principles, but they kind of have proprietary things, and it gets confusing figuring out, what you need in Humminbird versus Lowrance or Garmin. Things like Ethernet hubs, Ethernet cables, heading sensors, how many heading sensors you need, can you tie stuff together. So my goal here is to basically simplify that so you're not confused, and if, whatever brand you go with, you can look at this video and you can figure out, okay, here's what I need to order. So when I get started, I'm not like, oh, well, I don't have this extension cable, or I don't have this adapter, or this heading sensor or something, and now I can't finish my install and go fish with it. As far as this video goes with installation, the things I'm going to focus on are transducer placement, power, how you're running your power to your graphs using adequate size wire, also having the adequate battery size so you're not running your battery down and getting low voltage and causing you issues. I spend a lot of time on a lot of forums helping people out with Garmin stuff, Humminbird stuff, Lowrance stuff, and I'd say the most common factor in a lot of issues is improper installation, whether that's the placement of the transducer or inadequate power. You're going to spend all this money on electronics. You just want to spend a little bit extra money to get the proper installation so you have the best results you can get with the equipment that you bought and get all the potential out of it. All right guys, we're going to talk about wiring here, getting the proper power, wire size, battery selection. So you get your electronics ordered, you figure out what you want. Your next step is going to be figuring out how you want to wire it up and then how you're going to have everything laid out. Okay, so before we start laying everything out here, we need to do a little bit of research and figure out what size wire we're going to need, and we're going to have to figure out what type of battery we're going to need to power all of this. So what I listed here are just some examples of some max amp draws. Now this is not the amount of amperage that the unit is going to be typically using, but this is the maximum amount that they list. You can find this information if your unit's not listed on here on the website, or in the owner's manual, usually listed under specifications. And we'll keep in mind here that Humminbird is measured at 12 volts, Lowrance is actually measured at 13, and Garmin states theirs is measured at 10. So Garmin's is going to show a little bit higher because it's at 10 volts. If you step down Humminbird to 10 volts and you step down Lowrance to 10 volts, they're all going to be very similar, because as you go lower voltage, your amperage actually increases just a little bit, but on these smaller circuits right here, it's only 100 or 200 milliamps, so it's not a big deal. And as you can see, as far as forward-facing sonar goes, live scope and active target are pretty close, and Humminbird Mega Live comes down less than an amp. So we need to take the max amp draw for all our units on our boat and any accessories such as forward-facing sonar, 360 imaging, if we have a structure scan box, and then we're also going to add 1 amp to account for anything like heading sensors, and then also for a NMEA network. I'll just make up an example here of how a boat would be set up, and we'll kind of go over it to help you understand the process. We're going to have 3 units at 3 amps, just call it 3 to make it easy math, plus forward-facing sonar at 2 amps, round that up to make it easy. Then we're going to have our GPS puck and our NMEA. That's going to add an amp, so that's going to give us 12 amps at the max current draw. Keep in mind, this is not typically what it's going to be using, but this is the max that it can use, and this is how you want to calculate this, because bigger is always going to be better in your electrical circuit. So you have 3 good options here to lay out your boat as far as wiring goes. Option number 1, we can run dedicated wires to each unit. That won't require as big of a gauge of wire, but you will need more wire if you have more than 2 units, because you're going to have separate runs to each one. Option number 2, you can run dedicated wires to both the console and bow that will feed multiple units, but that will require a larger gauge wire, but it will be a cleaner look and makes future upgrades easier, because if you want to tie something in later, you do not have to run a whole separate wire. You can just open up the panel where it's at and add it to it. Option number 3, which is what I have on my boat, is run a larger gauge wire to a dedicated fuse panel just for your electronics. Make it clear that this is a dedicated fuse panel just for electronics. It is not your accessory panel on your boat that has like your live well switches and all that on it. You do not want to tie into that. That is not adequate power, clean power, and usually does not provide the greatest connections. Next step is going to be selecting the proper wire size for which layout you have. I'm going to have an example here of each layout to help you kind of determine what wire size you might need, but you might be wondering what voltage drop is. In the simplest form, without getting into all this in the science aspect, just think of it as voltage loss from the source to where it's traveling due to resistance in the wire. There's always going to be some sort of resistance in the wire that's basically using up some of the voltage to get the current where it needs to go. So the amount of amperage affects how much voltage drop there is. So it's extremely important to select the correct wire size, or you're going to get large voltage drop and it's going to set you up for problems with your electronics. Let's look at option number 1. We're going to use our previous example of the 3 HDS Live 12s in a forward-facing sonar. So we're going to have 2 bow units in a forward-facing sonar and 1 at the console. But for this option, we are going to have separate runs for each unit. So we have one that goes to the bow for HDS-12, another that goes to the bow for HDS-12, one for forward-facing sonar, and then one that runs to the console for the unit there. Again, you have more runs, but you can get away with a smaller gauge wire. So here's a little bit of how you get into calculating the voltage drop. Once again, the easiest thing is just to use an online calculator that does all the math for you. But if you like doing math, the formula is up there in the right-hand corner. So again, reiterate that this is separate runs to each unit. So the benefit of this is your amp draw will be calculated per unit. So you'll have a much smaller amp draw. Remember, our max amp draw for the HDS Live 12 is 3 amps. So if we use our longest run as an example, which is 20 feet, and it had 3 amps on it, here is the voltage drop for each of these different sizes of conductor. As you can see, number 8 has almost no voltage drop. Number 10 has a very low voltage drop. And number 12 is still pretty darn low. So if you wanted to, you could run number 12 from the battery to the bow and power an HDS Live 12 and have an acceptable voltage drop. Number 10 would probably be ideal, but number 12 would definitely work. And number 8 would be pretty overkill for just one unit, but hey, it wouldn't hurt anything if you have it laying around. So we'll move on to option number 2. We have 2 HDS Live 12s at the front, forward-facing sonar, and one at the console. And in this example, we have 2 main runs. So we have one to power everything at the bow and another to power everything at the console. So this is a little bit of a cleaner look, but it is going to require a larger gauge wire. So you have a first run going to the bow. This one goes to the console. It's going to power everything there. So like I said, only 2 runs, but you are going to need a little bit larger gauge. So we'll get into the math. Now you have to think about this one just a little bit different because you have to take into the account the max amp draw for everything connected to each main run. So we'll say the bow run, we have the 2 12-inch units plus forward-facing sonar. So we have 3 plus 3 plus 2. That gives us 8. And the console run, we just have 1 12-inch unit plus the NMEA, so that gives us 4 amps. We do the math here all the way to the bow, 8 amps at 20 volts. You can see you're going to have to use a little bit bigger wire to eliminate some of that voltage drop. Number 6, very low voltage drop. That'd be an excellent choice. Number 8 would work very well too. Number 10 would still work. You're starting to get a little bit higher. And number 12, I ran the numbers on it. I think that was like 0.6. That's way too high. You do not want to use that. Number 8 would probably be a solid choice. Number 6 if you want to go crazy. As far as the console run goes, you can see you can get away with a little bit smaller wire because it's half the distance and it's half the amperage. So number 8, you're basically losing almost nothing. Number 10, you're basically losing almost nothing. And 12 is still very low. So 12 would be adequate for that. So finally, we'll go to option number 3, the exact same setup. 2 units at the front, forward-facing sonar, and 1 at the console. And this is 1 run to a dedicated fuse panel. Then you're gonna have smaller runs to each unit. So here's our main run, goes to our fuse panel. And then from here, you're gonna have a bunch of smaller runs going to where they need to go. So you have 2 going for the bow units. You have 1 for forward-facing sonar and 1 going to the console. So assuming you have a 20-foot boat and you're going to put the fuse panel in the starboard rod locker just in front of the console a little bit, I put in 12 feet of wire. You must take into account the total max amp draw for the main run, and then you can individualize it to all your different units. And you can see from our previous math, number 12 would probably work to each individual unit. But as far as the main run to the fuse panel from the battery, number 6 or number 8 is going to be your best bet. Number 10 is still acceptable, but I'd feel a whole lot better with at least number 8. That way you have minimal voltage drop. And like I said, in my boat, I actually have this fuse panel set up and I went ahead and ran number 6. We'll talk about batteries real quick. I'll just keep it really basic. I'll have another video at a later date, a little bit more in depth on batteries, but I'll just get you the info that you need here. So you have 3 different types. You have your basic lead acid, you have an AGM battery, and you have a lithium battery. Lead acid batteries still get the job done. They're relatively inexpensive. Kind of think of it as your traditional car battery. Sometimes it's a little harder to find them in the dual cycle battery. Good brands for some lead acid batteries would be like Deca or North Star. Within the battery market for all these, a lot of them are made in the same place and they just have a different brand label stuck on them. But if you get Deca or North Star, you know it's a quality battery that is made in the US. AGM is absorbed glass matte. It's similar to a lead acid. They usually have a little bit better specs on them. They are more vibration resistant. They are totally sealed. There's nothing that can spill out of them. Usually easier to find them in a dual cycle style battery. What I mean by that is a starting and deep cycle battery all in one, which is important, which is really handy in the marine industry. You need a lot of cranking amps to get these big outboards started, but you also want to get the benefits of the deep cycle battery to help run electronics and pumps. Lithium batteries are kind of the new thing in the marine industry. You can get one that can deliver about the same amount of power, at least in the deep cycle aspect, as a AGM battery and be half the weight. Are expensive, they're coming down in price, but depending what company you go on, they also have a really good warranty. This green top battery I have pictured here is an Expion 360. That is a good company. They are actually writing the laws kind of with the Coast Guard of what needs to be a standard for lithium batteries in the marine industry. Once again, with the lithium battery market, you're getting a lot of batteries that are made in China and they slap whatever company's label on it and they send it over and market it as whatever. But you do get what you pay for, usually in terms of batteries. And I wouldn't want to put a really cheap lithium battery in the back of my boat that can possibly have some sort of explosion or something, especially with all the fuel on board. You also have to have a special charger to charge lithium batteries, and they do not charge below 32 degrees Fahrenheit. That is not saying if the air temperature is 32 degrees Fahrenheit, it will not charge. But if the battery core temperature itself gets below 32 degrees, it will not charge. I have a battery management system inside the battery. It will not charge if it gets too hot or gets too cold, and will not let it deplete down to a certain point. Technology with them will get better, they'll get cheaper, so eventually people are going to start shifting more and more to lithium batteries. As far as the size of batteries, they're going to come in different groups. They're going to have size 27, 29, 31. Get a group 31 battery if you can fit it in your boat. Have a lot more power throughout the day, especially if you're running multiple graphs, live scope. You'll end up kicking yourself if you have room for a 31 and you do not get one. So batteries are basically rated in reserve capacity or amp hours. I'll give you a little example of those. Reserve capacity is basically hooking up 25 amps of load to a battery and timing how many minutes it lasts. I know this X2 battery, just off the top of my head, that's what I run on my boat, has a 220 minute reserve capacity. So that means you have 220 minutes of runtime at 25 amps on that battery. That is pretty impressive. And then you have your amp hour, which is normally calculated at a 20-hour discharge rate, which all three of the batteries I have pictured here are either 100 to 120 amp hour batteries. Keep in mind that the lithium is only a group 27 because that is the largest they make right now. But we'll just go to a 100 amp hour battery to make the math simple. You have 20 hours at 5 amps. You can also read it as 10 amps for 10 hours. Just take your amp hour rating on the battery and divide it by however many amps you're going to draw, and that's how many hours it's going to last. So that's kind of the unit of measure that battery manufacturers use, so you can determine how much potential energy is stored in there. And to reiterate again, the best advice I can give you is to get the biggest size battery that can fit or you can afford in your boat. You will not regret it. Before we get into anything else, we'll talk about wire type and we'll talk about master cutoff switch. So as far as wire type goes, you want some sort of fine stranded copper. That's going to be your best bet as far as flexibility. It's going to crimp nicely. You can get like a marine grade wire such as Anchor Marine, which this here you can see is like a Romax, kind of like in a house, just like a duplex style, just have a positive and a negative. They make it in different size wires, think all the way down to number 6. And then you have other marine grade wire. Think of something you could get like at West Marine or other places online that are essentially the same thing. They just won't be in the Romex style, which Anchor does make it straight wire as well. And it doesn't necessarily have to be marine grade. That would be more important for like a saltwater environment just because it's so corrosive. Just make sure it's a fine stranded wire with quality insulation and you'll be good. The master cutoff switch, this is what we've always used in all of our installations. It's very important. Many things will stay on all the time and they will draw down your battery without one, such as forward facing sonar, NMEA network, if you have a structure scan box. And another big bonus is it isolates all of your electronics from possible power surges. Say you're plugged in somewhere and you get a power surge through the house, or if your charger malfunctions and starts giving more voltage than it should, this is going to help protect your electronics because the fuse that goes to your unit has no protection against voltage. That's only for amperage. So this would be your only safety net to protect you from over voltage. The switch is a Blue Sea M Series 6006. It's available pretty much anywhere online. As far as connections go, you can either solder, you can crimp, or you can use some sort of alternative connector such as these posi locks. I've actually never used these posi locks before. Kind of been seeing them around a little bit. I know the Sea Clear company uses them. I do not know if they use a basic size or if they get something similar manufactured for their harnesses. But a lot of people seem to like the Sea Clear harnesses, and I haven't heard anyone really complain about these style connectors, so I'm assuming that they work all right. As far as soldering goes, that's something that I usually like to do, but depending what wire configuration you go with, it can sometimes be a little bit of a challenge to solder the smaller wire from the head units to the larger wire that you run up to the bow or console area if you're just kind of doing one wire as your main feed. It is doable, but you have to have a little bit more experience in soldering. And then of course you always want to heat shrink over top of it to help keep any water out, but also to provide stability. What I really like to use and what we've used in the last couple installations are these butt splices, but with the heat shrinks built into them. I like these a lot because they're quick, they hold really strong, and once you heat shrink this down, the wire's not going anywhere. In addition to it being waterproof, it does provide a lot of stability to the crimp itself. And this is nice because you can go from different size wire. Say you have multiple units and you want to connect it to the end of the wire. but they're all a much smaller gauge, say 16 or 18, and you have multiple ones that want to go in to, say, a number 8 or a number 10. You can twist all of these smaller wires together and put it in to get to the appropriate size, or if it's a little bit too small, you can add a little bit in there and then give it a good pull on both directions to make sure everything's seated properly after you crimp it, and heat shrink it all down, and you'll be good to go. Another thing to consider is your mount. Another thing to consider is what mount you're going to use and what kind of configuration you're going to have. So there's a lot of good brands that have been out for quite a while that have been making mounts since electronics have become a little bit bigger part of bass fishing. You have Bass Boat Technologies, you have Deckit mounts, Precision Sonar, there's a bunch of other mounts if you look through Facebook or you go online. So do a little research and figure out maybe what you want, or maybe you have a mount and you're going to do a little bit different setup. You can modify it and make it work. So here's kind of what I had going on my boat. I had a single Deckit mount that just had an HDS 12 on it, and when I added live scope, I wanted to have room for another mount to have them stacked vertically, but I couldn't find anything that I was really crazy about, so I ended up just making my own. I took an aluminum plate and I laid it on top of my Deckit mount, and then I laid everything out as far as where I wanted the units to go, and then I had some reinforcing underneath that connects to the bow shroud area. Then I put it all together and test fit it, tried it on the water, liked it, so then I got it powder coated and put it on the boat, and that's how it's been ever since. Okay, now as far as transducer installation here, I'm going to be talking mostly about side scan transducers here. You're going to have two options here with this as well. You can do an installation kind of like what I have here, which is off of the jack plate, so they actually have a plate in between each side of the jack plate, and kind of like a, I don't know what you want to call it, hole shot plate, just a plate in between. And then I have the transducer off the bottom here. In my old boat, I had like little spacers that came off here, kind of held the transducer off to the side. I'm really a fan of this installation just because you're not putting it directly into the boat. You know, you're not drilling holes on it, you're putting it on the jack plate. I just prefer that method a lot more. Now, if you are going to put it on the boat, you have a few different options. You can put it kind of over here, you know, same height basically. You can go underneath and kind of go off to the side like this. Would be a good spot to put it. You don't really want to go any lower than that. There's really nowhere good to mount it on this boat. Some boats you can put it like in this zone here, but I'm not really a fan of that because the lower you go down in this area here, you know, the better chance you have of getting this thing knocked off. Ideally, you do not want it in front of, like it directly in front of a strake here on the boat. You know, things that give you turbulent water. You want this basically to be in the cleanest water. And then the most important aspect of this, if I can get my little kayak to move here, is when you are looking left and you are looking right, you have nothing impeding your sonar. Your sonar for your side imaging and stuff is going to be going straight out this way, straight out this way. You know, so if you have something in the way, you're obviously going to have blockage on your signal and you're not going to get good pictures. Some boats, if you trim your motor all the way down, it will kind of get in front of it. It's still not in the way, but that would probably affect your picture slightly. So if you can tilt it up just a little bit when you're actually side scanning, and get you a little bit more room in there, you'll have a little bit cleaner pictures. That's basically the gist of your side imaging transducer installation, whether you have Garmin, Humminbird, Lowrance. This bracket, I bought this boat used, so I'm not sure which bracket they use. It kind of looks homemade, but if you want to buy one, a good brand is Transducer, Shield, and Saver. They make transducer mounts basically like this for Garmin, Humminbird, Lowrance. One other thing I do want to mention that is also very important is the level of your transducer. You either want it to be perfectly level with the boat as it's on the trailer, get everything level, that will be sufficient. Or if you're really, really picky and you want the absolute best picture possible, you should actually have the rear of the transducer, the end that is closer to the motor, be a little bit higher than the end that is closest to the boat. And the reason for this is when your boat is idling, it's actually sitting lower in the rear than it is in the front. So it's not sitting perfectly level in the water. There's two different ways to replicate how your boat is sitting in the water while you're idling. And that is this method here with the old coin trick and the level. The stack of coins underneath it while you are in gear idling until the bubble is level. And then you take that stack of coins, you do not mix them up, you don't lose them. You get home, you get the boat on the trailer, you put it back on the boat exactly how it is pictured, and then you use the jack on the trailer to get it level again, and that is how your boat sits in the water. And then you can make sure your transducer is perfectly level at that point on your jack plate or however it's installed to your boat, then it will be level to how your boat idles in the water. Now, if you don't want to bring a level and a bunch of coins out there, you can just use your phone. Set it on the inside on a surface, or you can set it on the gunnel, kind of where the level is here, to make sure you don't drop it in the water. And then when you get home, you can just replicate the same thing, get it to the same degree mark that it was, and then check your transducer from there. Before we go any further, I want to talk about the NMEA 2K network. So I know this says this is for Lowrance, but Lowrance and Garmin are basically identical setups on this. They both utilize the NMEA 2K for their GPS pucks and heading sensors and stuff. Humminbird does not use NMEA 2K for their actual system. But with any of the brands, you can use the NMEA 2K network to connect to your motor. You can get RPM, fuel tank levels, alarms, depends what accessories you put on the boat that attach to different components. So to quickly sum up what the NMEA network is, it's its own little circuit. You can see it's connected to a battery, and it powers this and basically just sends data back and forth. So everything you have connected to this little network can share its data with each other. So in this example, you have your GPS puck back here, you have a console unit and a bow unit. So with all this connected, you can share your heading and your GPS waypoint position with both of these units. The same thing goes for Garmin. So these little T connectors, as you can see, you can screw them together, so you could add multiple in a row if you had multiple things dropping in at the same spot. You basically have little drop cables that come down, connect in, they have different lengths, and then you have your backbone cable, which just goes in between. So say you're at the console and you need to go up to the bow, you would get a backbone cable, that's a little bit longer, that goes up to the bow area where you can add more connectors. Same thing if you have to go back to the stern of the boat towards the battery. One thing to note, it does need to be on a switch. If it is not on a switch, it will constantly be drawing power and will draw your batteries down. And the other very important thing is these terminators. They are little resistors. If you do not have these, the network will not work. Let's talk about the Garmin Network. This is basically what you're going to need, or maybe what you're going to want. Here's some must-have and commonly needed cables. You have your large end network cables, also known as Ethernet cables. Then you have your GPS 24XD, which is a puck and heading sensor all built into one. Then you have a GMS10 Ethernet hub. You may need this in certain situations. I'll go over that. Then you have your NMEA 2K starter kit. This is from Garmin, gives you 2 T connectors, 2 end cap resistors, your power cable, and then a drop cable / backbone cable, just 2 various length cables. Now, I will note that you do not have to buy NMEA 2K stuff from Garmin. The NMEA 2K is just like a marine standard between all brands that choose to utilize it for ways to basically transfer data efficiently. Then you have your network cables. These are the small ends. Notice on the large end here, it screws into the back of the unit. These are the small ends. This is the network cable adapter you're going to need for live scope, because it comes with a really short cable. So if you want to move it around in your boat a little bit, you can get like the 6-foot cable that has this on both ends, and that'll get you by. And then another thing, remember, for each unit you have, you're going to want to get another drop cable or just a shorter NMEA 2K cable. Here is a little network map for GPS map and the Echo Map Ultra series. I went ahead and kept the power out of it just because with all the power going to each unit, it gets cluttered. So just kept it simple with your transducer, your Ethernet, and your NMEA 2K. Like I talked about earlier, make sure everything is on a master cutoff switch. Otherwise, you're going to have things drawn down your battery, such as your live scope box or your 24XD GPS puck. Your Ethernet shares your maps, waypoints, sonar, things of that nature between each unit. Your NMEA 2K network is here to link your 3 units in this example. So this 24XD puck has a heading sensor and GPS built in. So you can share the heading between all these units through the NMEA network. So that's going to allow you to have good heading between all the units. Say you're fishing and you're not moving, you're not going to get that screen spin because it doesn't know which way you're pointing. It's always going to know which way your bow is facing. But it'll also allow you to separate your GPS and your heading per unit, and I'll explain what I mean by that. So these 2 units are on the bow, and you do not want to use this GPS puck as the coordinates if you mark a waypoint up here, because you're going to be about 20 feet off. So you can actually use the internal GPS for the unit, but still use the heading from this puck, and that takes care of that issue because you're going to be using the GPS coordinate from inside this unit, but you're still using the heading on that puck. And the same thing goes for this. For your console unit, you want your GPS puck to be close to your transducer, and you also want to use the heading from this puck. That way you get accurate waypoints in that regard and you're not offset by 10 feet or so. One thing to make note here is your GPS map and your Ultra series have 2 Ethernet ports per unit, where your Echo Map series only has 1. I'll show you why that makes a difference, because as you can see, you can have 2 units at the bow, you can have your live scope, and you have another at the console, and it's all Etherneted together, and you don't need anything extra. But if you just have an Echo Map series, they only have the 1 port. So now you can't go from unit to unit to unit and have live scope. That throws a wrench in your plans. So if you want that, you're going to have to get this GMS10, which is an Ethernet hub. They run about $200, $250, somewhere in that range. So if you keep that in mind, it's actually sometimes more cost effective to get an Ultra series instead of an EchoMap series. So a recap of some things to consider. Like I was talking about, your EchoMap UHD series only have one Ethernet port, where your Ultras have two, or your GPS map. So if you're running multiple EchoMap UHDs, you may be better off just getting an Ultra series or a GPS map series. And to reiterate what I was talking about with the GPS puck, is just you can place it near the transom transducer for accurate waypoints and then use the heading. And then you can share the heading to all the units and then use the internal GPS for the bow units to mark accurate waypoints up front. And one other reminder is to make sure you install everything on a main battery cutoff switch, or it will definitely draw down your batteries when you're not using them. Next, we'll talk about the Lowrance network. Same thing, what you'll need or want. You have Ethernet cables, you have your 0.1 antenna, which is a GPS and heading sensor puck. Then you have your NMEA 2K starter kit and just extra NMEA drop cables. And the NMEA 2K starter kit, or NMEA components in general, are not proprietary. Do not have to buy them from Lowrance. It's a marine standard. You can buy the components from anybody, no worries. Here's an example of a Lowrance network. You have a transducer, Ethernet, NMEA 2K. Your Ethernet shares waypoints, maps, sonar. Your NMEA 2K shares 0.1 heading to all the units, and it also shares info to the Ghost trolling motor if you have that installed, such as following contour lines. 9-inch or larger HDS units have 2 Ethernet ports per unit. That goes for the lives, the carbons, and I think maybe even the Gen 2s. So that gets you a lot of options with networking. You don't have to worry, you can put a lot of units in the boat and have other accessories that use Ethernet cables, and you will have room. If you are using a smaller unit or an elite unit, they only have one Ethernet port, and you're going to have get an Ethernet hub, and that runs around $200 to $250. So sometimes it's more cost effective just to get a little bit larger HDS unit, and then you don't have to deal with the Ethernet hub. So then in your NMEA 2K network that is connecting all the units to the 0.1 antenna, this is a heading and GPS sensor. So what you can do is use your heading for all your units. That way, if you're sitting still fishing, you have a good clean line. You don't have the donut map spinning because you don't know which way your boat's pointing. And then you can utilize the internal GPS of your bow units to mark accurate waypoints up front near the trolling motor. But you can share the heading still with that. So you can separate which GPS position it's using. You can use internal, but use the heading of the puck. You could do the same thing at the console, but you're better off setting up using the puck and putting it near your transducer. And then you use the puck position for your GPS coordinates for the rear of the boat, and you use the heading sensor as well. So just remember, if you are running the Ghost trolling motor and you want that to follow the contour lines, all you have to do is plug it into your NMEA network, so you'll have to have another T connector up front. Some things to consider, and just to reiterate them, is the elite units only have one Ethernet port or the 7-inch HDS. So if you're going to get active target or using a Ghost trolling motor, it just may be more cost effective to get HDS units 9 inches or bigger, so you're not required to buy that Ethernet hub. And then your NMEA 2K allows you to place your 0.1 puck near the transom transducer to get accurate waypoints for the back, so you don't have that offset on the units. And you can share the heading with the bow units. And then you use the internal GPS on the bow units for marking waypoints, so that's accurate and not offset at all. And then a big reminder to install all your electronics on a main cutoff switch in the rear compartment. All right, the Humminbird network. So here's what you'll need or want for Humminbird. So you have Ethernet cables, pretty standard. Then you have an Ethernet adapter cable for Helix units. So you can see here, you have your regular Ethernet cable for Humminbird, which is like a metal threaded connector for male and female. And then you actually have this little plastic piece. Helix units basically have a cradle connector, and this piece slides into the cradle connector and actually goes to the unit. Then you have a NMEA 0183 splitter cable for the Solix units, because it does not directly take the connector that the heading sensor puck takes. And then that's the last thing on here, which is just a GPS puck with the heading sensor like Garmin and Lowrance have. Now, kudos to Humminbird for having these graphics of their network to help you figure out kind of what you need. They are the only manufacturer that I found during the making of this video that has this sort of option to help you understand what you need. We'll look at a really basic network here real fast, which is just 2 graphs. So Humminbird is good also about laying this out. They tell you exactly what you need for your Helix series or an Apex or Solix series. So if these are both Helix units, you need a regular Ethernet cable, plus you need this Ethernet adapter cable up here. And then from here, you would have a transducer cable going out to the front of the boat. You have a transducer cable here. They show you 2 transducers. If you want to run a splitter so you have depth on plane, you can epoxy one in the hole and then have one outside on the boat, your regular side imaging. And they sell this splitter cable here. And it will automatically detect if your side imaging transducer is out of the water. It will go to the through hole reading. In this example, they only show 1 GPS and heading sensor puck, and that is true if you have
Apex or Solix series. But if you have Helix series graphs, you need 2 of these pucks, and I'll explain why. So with the Apex and Solix series, you can put this puck here in the rear of the boat near your side imaging transducer, and you can use the heading from that puck for this graph and this graph because it is shared through Ethernet on the Humminbird network. And on the console graph, you can choose to use the GPS puck as the location when you hit a waypoint. And then when you go to your bow unit, use the internal GPS for when you mark a waypoint, but you can still reference the heading from the back of the boat, sharing it through Ethernet. Now with the Helix series graphs, you can't do that. It's a one for all. So if you have your heading sensor GPS puck back here and you try and share it through the network to your bow unit, this bow unit is still going to use this location when you mark a waypoint. Now granted, it'll still be the same heading, but your waypoints are going to be off by about 20 feet. So what you need to do is get another GPS heading sensor puck up here and have it connected to your bow unit. It's pretty annoying. It's an added cost. You know, those pucks are not cheap. They're around $200. That's just the way Humminbird has done it. Now we're going to look at this graphic. Now don't get overwhelmed with all the lines because they have all the power going to everything, and they also have a Talon, and they have the trolling motor, and it also has a Mega 360 imaging on it. The main reason I want to show this graphic is because of this Ethernet port right here. All of the Humminbird units only have 1 Ethernet port per unit. So if you have more than 2 units on your boat, you automatically are going to need this Ethernet port, and that'll run you about $260. The only way you're able to get away without the Ethernet port is if you are running Apex units, which right here, that is their top of the line, their flagship model. And I believe they either have enough ports to run without the adapter, or they have some sort of Wi-Fi type networking. So you're going to have the same thing with the Ethernet cables. If you have Helix units, you're going to need this adapter. If you have Solix or Apex, you don't need an adapter. And the heading sensor is the exact same setup as last time. You can share it between as many graphs as you'd like. If you have Apex and Solix series and only need 1 puck. If you have Helix series, you're going to need a puck at the bow and a puck at the rear. Now some things to consider. The Humminbird kind of just does their own thing and have things that are very specific. What I mean by that is not all units have the same capability. They don't all do side imaging or down imaging or sonar or even have any network capabilities. So the cheapest model would be one that only does GPS and doesn't have any networking capabilities. And then from there, you know, it would have GPS plus network. And then you'd have one that can do sonar and GPS plus network, down imaging, sonar, GPS network, so on and so forth, all the way up to where it can do side imaging plus all of the above. So it just kind of keeps building on itself. So you need to double check you get a unit that is capable of doing what you want. Now it's kind of nice in some terms because if you want 2 units up front and you know you're only going to use one for mapping, you can get one that only has mapping and network capability. You don't have to spend the extra money to get one that can do side imaging and down imaging, even though you're not going to use it on that unit. Kind of example of what their flagship model that can do everything for like a Helix would be a Helix 12 with Chirp, which is a sonar, and then you have Mega side imaging, plus you have GPS. It's a generation 4 and the N stands for networking. So if there's no N on the back, that means it is not capable of networking. Like I talked about earlier, if you have Helix units and you want the most accurate waypoints, you're going to need 2 of the heading sensor GPS pucks. Another thing is Humminbird 360 has had the market 2012 when it came out, and now they have Mega 360, which is just even more high definition than the original 360. If you have Mega 360 and you combine that with some forward-facing sonar, that is hands down the best structured fishing setup out right now. And finally, make sure to install all of this on a master cutoff switch.
All right, so we're at the back of the boat. I'll pop this open and I'll show you kind of what I got going on. So here is my starting battery. It's a size 31 X2 AGM. And basically, I've got a number 6 here and a number 6 here, and it runs over to this blue C cutoff switch. So if I kill this switch like here, all my electronics have no power. I have the same thing for all my accessories and stuff on the motor. So it goes from the positive to the switch, and it comes out of the switch, and it goes up here to my rod locker. So here's where it kind of gets crazy. So you got a bunch of wires coming in and coming out. So here is the fuse panel. It's a blue C's fuse panel. So this, you got some number 6 coming in right here. For the top side, it's positive. Then you got your number 6 coming down in the bottom here, and the bottom side is just all your negative terminals. And if you, in the top side, it's hard to see through here, and I'm not going to take this off because it's kind of a pain. You have all your fuses in here, so if you ever have to change one, something blows, they're easy to access. That's what I keep in this little red bag right here. Is all fuses and stuff for my electronics. And you can see I also have my live scope box mounted here, and a structure scan 3D box over here for my Lowrance. So from this point, you know, my wires go to the bow that need to go to the bow, and they go up into the console area for the ones that go there. And then up front, I just have 2 units.
So here's some final thoughts. If you take the time to plan out your electronics before you order all your stuff, you're going to be way better off. I like to draw my boat on a piece of paper and then kind of start to lay everything out as far as where the units are going to go, what I'm going to have them mounted on, where I'm going to put fuse panels, what kind of cables I'm going to need, how long of cables am I going to need. I just like to lay everything out and kind of make a list. That way, I know I'm going to have all the components I need to do my installation the first time. I'm not going to have to go back online and order some cables or something that I forgot. Now I'm not going to be able to use my boat or be able to use the electronics until I get everything back in. I like to have everything ready to go so I can get it done in just one shot. Use quality installation products. Don't skimp on it. Just take your time. A good installation is all that separates your great unit performance from poor unit performance. You've already spent all this money on electronics. Just spend a little bit more to do the installation correctly. And if you're keeping your boat for a longer period of time, I would advise using a larger gauge of wire, because inevitably they're going to come out with some other type of technology that you're going to want, and you're better off just having a larger size wire that can handle more load and not be on the brink of it. So that way you don't have to pull in all new wire or do anything major. You can maybe just open up one portion of your boat and install whatever it is. And finally, once you figure out what brand you're using and all their proprietary names, you'll see that it's really not that complicated. It can get a little confusing switching from brand to brand and trying to figure out what's what and what you need and what they call it. But once you kind of break it down, you'll realize that they're all pretty much the same. So hopefully this video will help somebody doing some electronic installations, whether that's a certain part of the installation, or you're trying to figure out what brand you want to use, or you know what brand you're going to use, but you're trying to figure out what cables you need, adapters you might need, or just trying to find more information on their network. So like I said, this is going to be a series. Installation, in my eyes, is one of the most important aspects of all this. So in the next video, we'll focus on 2D sonar and mapping. Thanks for watching, guys.